Today we learn about the different cells in parallel. So previous class we learned about the same type of cell or identical cells in parallel, and today we learn about the different cells in parallel written here. So I'm going to draw a diagram here. So already drawn here. So this one is this is resistance. This is E1. This is R1. This is one cell, and this is E2 and R2. This is another cell. Okay. So I current is passing in this direction, and it will be split into two parts, then I1 and I2. Then it will join. I current will join. And Kirchhoff's law is applying here. So there are two cells here. So going to draw with the colors. So two cells. This is one cell. This is one cell, and this one is another cell. The two cells are there. Now, what is the meaning of the combination of cell is that with that combination we will draw one cell like this, same X point, then this is a Z point. I current is passing in this direction, so we will get the equivalent cell here. That means instead of these two cells we are going to get this cell. So this is called E equivalent, and this is called R equivalent. Okay. So now we find out that what type of equivalent, what will be the value of this equivalent resistance with this E1 and E2, and what is the equivalent internal resistance with R1 and R2. So from here you can see the I has divided into two parts, that is this I current into I1 and I2. So you can write, so I current is supplied by the cells, then the main current is given by, so if I1 and I2 current is supplied by the cell, then the main current is given by I is equal to I1 plus I2. So now both the cells are having the same terminal potential difference. So this is a V is same for both the cases. V is called the terminal potential difference, already we told in the previous video. So V is the same terminal potential difference. So write down V is equal to same terminal potential difference, because they are connected in parallel. So now from the first cell, what you can write from first cell, what you can write? You can write V is equal to E1 minus I1 R1, and so I1 will be equal to, what? E1 minus V by R1, and from second cell V is equal to E2 minus I2 R2. So I2 is equal to E2 minus V by R2. Now we put this we can keep the equation number 1. So we put this value I1 and I2 in equation number 1. So putting the value of I1 I2 in equation number 1, what we get? So we get I is equal to E1 minus V by R1 plus E2 minus V by R2. Now we'll do some calculation here. So E1 by R1 minus V by R1 plus E2 by R2 minus V by R2. Okay, so we'll take this one, E by E1 by R1 plus E2 by R2 minus V and 1 by R1 plus 1 by R2. So that thing we'll get from this solution, solving this type of thing. So now I also equal to, so you can solve this one. So you can R1 R2, then E1 R2 plus 2 R1 minus V, then you get R1 R2 by R1 plus R2. So this you will get. Let's see, no? Okay. So V is equal to, so that thing we got in case of R. So what will be the V? What is the value of V? So this is R actually. This is I. Sorry, this is I equal to. So we're going to find out the value of V from here. So V will be equal to, so E1 R2 plus E2 R1 by, so if you divide it by this one, so you get R1 plus R2 will come here. R1 plus R2. So you calculate this one, you get this one, E1 by R, this one. Or also you can do, you can multiply with R1 and R2. So this R1 and R2 will get cancelled. So I will become R1 and R2. So this thing you can calculate from it. So my I R1 R2 by R1 plus R2. This is the thing. Now this is the equivalent. This is the equivalent EMF, and this is the equivalent internal resistance. So you can compare this one. So you can write V is equal to equivalent. EQ means equivalent minus R I EQ. So this is the formula. Now what is the equivalent EMF? Comparing this both the things. I give the number. This is equation number 2, and you can give this is equation number 3. Equation number 3. So comparing 2 and 3, you can write E equivalent is equal to E1 R2 plus E2 R1 by R1 plus R2, and R equivalent will be equal to R1 R2 by R1 plus R2. Okay. Also you can write like this way: 1 by R equivalent is equal to 1 by R2 plus 1 by R1. So if you want to find out that E equivalent by R equivalent, then what will get? So you find E equivalent by R equivalent. So you get E1 R2 plus E2 R1, this one, by, so this R1 and R1, this will get cancelled, this one, no? So R1 R2, then will become E1 by R1 plus E2 by R2. Okay, or you can say that is E equivalent is equal to 1 by R1 plus E2 by R2 into R equivalent. So these are the formula. Now if you want to generalize these things, actually this is quite complicated, this one. Now we have to generalize the entire thing. Okay. So then if I generalize this one, I'll let the M cells up and right. So generalizing, so let M cells of E1, E2 and dot dot and EM are EMM internal resistance R1, R2 and RM be in parallel grouping. Then you can write, so 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by Rm, and E equivalent will be E1 by R1 plus E2 by R2 and plus EM by Rm. That what is R equivalent. That one thing we proved. Also, you can find out that E equivalent by R equivalent. So now we'll get ink has finished. So E equivalent by R equivalent. E1 R2 plus E2 R1 by R1 plus R2. So we solve this one. So E1 by R1 plus E2 by R2, and that is E equivalent will be equal to same thing, that is E1 by R1 plus E2 by R2, and then R equivalent, like this way, whatever we proved previously, like this way the formula has came. So normally generalizing M cells of EMF E1 and E2 and these things, and generalizing R1, R2 and grouping, so then you can write this one. This is the equivalent resistance and internal resistance, and this is the equivalent EMF. So that is the actual thing. So next class we will continue with the mixing grouping of cells. That means as well as the series cells will be connected, and also the set of series cells will be also connected with the set of parallel combinations of the cell. So I think a little bit you understood this one. So let's practice in home. Okay, thank you very much.